Welcome to the deep dive. Today we're jumping into something pretty critical for global logistics. We're looking at extended reality, XR, and how it's changing things for the maritime workforce.
Yeah, it sounds maybe a bit niche, but you have to remember something like 90% of everything you own, everything you touch, it probably got here on a ship.
Exactly. So if the people operating those ships or the equipment in the ports aren't absolutely precise, well, the whole global supply chain can grind to a halt.
And right now, that precision is really under pressure. The sources we looked at paint a picture of, well, a perfect storm, really.
A perfect storm. How so?
You've got ongoing port congestion, which leads to, accidents, equipment collisions. Then there are these really high consequence incidents on board ships, fires, flooding, serious stuff.
Okay.
Add to that stricter rules all the time from bodies like the IMO, SOLAS, plus the risk of cyber attacks, which is very real now. And underneath it all, a massive talent gap, just finding enough skilled people.
Right. And that really hits the core problem, doesn't it? Training. How do you actually prepare someone for those, like, once-in-a-career emergencies?
Well, the old way. It's tough. Classroom stuff, sure. Maybe shadowing someone on live equipment, some drills. But they're infrequent, expensive.
And you definitely can't simulate, say, a major engine room fire safely on a real vessel. Or navigating a huge ship in a storm where it might actually capsize. It's just not possible.
Precisely. And that's the gap XR is aiming to fill. It offers practice that's repeatable, you can measure performance, and crucially, it's safe, even for those high-consequence events.
Okay, so our mission for this deep dive is clear. We're unpacking how EON Reality's XR Library Premium tackles this, specifically looking at 4 priority training groups they've identified. It all seems to hinge on digital twins and this thing called spatial AI.
That's the core of it, transforming skills using these new tools.
Right, let's get into it. Priority 1 you mentioned is about tackling those immediate risks, things that improve safety right now and keep the ports running smoothly.
Exactly. Reduce risk, improve throughput. And this priority breaks down into 2 main training groups. Group A is all about port equipment operator training.
So the people driving the giant cranes and loaders, handling those massive high-value assets.
Yes. The sources get really specific here. For quay crane operators, for example, it's simulating things like getting the spreader aligned perfectly over the container, controlling the sway, which is harder than it looks, handling tandem lifts where you pick up 2 containers at once.
And doing all that under time pressure, following safe lift plans. I imagine one mistake there is incredibly costly.
Oh, absolutely. Millions in damage, potentially, not to mention injuries. But it's not just the key cranes.
Okay.
Group A also covers straddle carrier driving. These are the tall machines that move containers around the yard. So practicing tight turns, making sure stacks don't collapse, avoiding obstacles in really busy areas.
Right, those yards look chaotic.
They can be. And then terminal tractor operations, the trucks moving containers around, drilling gate moves, getting chassis position right, and importantly, handling live reefers refrigerated containers, making sure they maintain power. That's critical.
The sources mentioned a pretty striking use case for new recruits, right? Something about simulated vessel calls.
Yeah, the goal they cited is for a new quay crane operator to complete something like 30 or more simulated vessel unloading cycles in XR, mastering things like anti-sway, twin lifts, all before they operate over a live deck crew.
Wow, so you're essentially compressing maybe a year's worth of high-risk practice into weeks safely.
That's the idea. Massive risk reduction up front. You nail down those high-frequency safety issues in the port first.
Which then logically leads to the other part of priority 1, Group B, things that happen at sea.
Exactly. Group B is vessel emergency response drills. This is where XR really comes into its own because you're simulating scenarios that are just too dangerous or disruptive to practice live.
And these are aligned with the official standards, like SOLAS.
Absolutely. They have to be. We're talking SOLAS standards safety of life at sea, so things like comprehensive firefighting at sea simulations.
What does that actually involve in this simulation? Is it just point and click?
No, it's much more involved. It's about detection, identifying the fire source, practicing boundary cooling to stop it spreading, activating the right fixed systems, CO2 maybe, handling specific risks like oil leaks or hot work incidents sparking a fire.
Okay, quite detailed. What else besides fire?
Damage control is huge. So practicing isolating a whole breach, managing progressive flooding where water keeps coming in, using shoring to support damaged structures, deploying portable pumps correctly.
And the ultimate emergency, of abandoned ship.
Yes, abandoned ship drills too, covering the whole process. Muster stations, operating the lifeboat davits, man overboard procedures, especially in rough seas where it's incredibly dangerous.
So how does this XR drill actually prove someone's more competent than, say, the traditional drill where an officer watches and ticks a box?
It's about the data and the repetition. The sources describe crews repeating, say, an engine room fire scenario until they consistently meet specific performance targets, like containing the fire, shutting down ventilation, restoring partial power, all within maybe a 5-minute window.
So it's measured. Objective.
Exactly. The system tracks every action, the time taken, the decisions made. It's not just subjective observation. It moves training from just did they do the drill to can they verifiably perform under pressure to standard.
That's a fundamental shift, moving from just participation to proven competence based on data. Okay, fascinating. Let's move on then to priority 2. This seems to shift from immediate crisis to more long-term stuff, engineering and navigation.
That's right. Priority 2 focuses on system reliability and decision-making. Group C kicks this off with marine engineering and engine room operations. Think preventative maintenance, system reliability, using digital twins of the actual machinery.
Digital twins, so exact virtual copies of the engines and systems.
Pretty much. So trainees can practice things like cylinder condition trending on the main diesel engines, learning to spot tiny changes in vibration or heat signatures that might predict a major failure down the line.
Preventing problems before they happen.
Exactly. And a huge part of this is compliance training, like executing fuel switching procedures correctly. That's vital under the IMO 2020 low sulfur fuel rules. Getting the changeover curves right as you approach port avoids massive fines, even ship detentions.
And if systems do fail, they need to know how to fix them fast.
Absolutely. So they drill troubleshooting complex systems, pumps, piping, diagnosing things like cavitation, which can wreck a pump, or figuring out why ballast transfer isn't working.
The source mentioned a specific example here, didn't it? A blackout recovery.
Yes, that's a powerful use case. A junior third engineer, a 3E, can practice a full ship blackout scenario in the XR environment, restoring power, synchronizing generators back to the main switchboard, doing it over and over until it's almost muscle memory.
So they handle potentially catastrophic failures in the sim, not for the first time on a real ship at 3 a.m.
Precisely. They gain years of high-stress troubleshooting experience safely, making sure they can meet those critical service level agreements if the worst happens. It helps bridge that experience gap much faster.
Makes sense.
Yeah.
Okay, so that's the engine room covered. But the ship still needs to get from A to B safely. That brings us to Group D.
Group D bridge and navigation simulation. This is all about boosting situational awareness and sharpening decision-making skills, especially when things get difficult or complex.
I assume this heavily involves the rules of the road at sea. Call regs.
Definitely. Intense practice on collision avoidance using call regs. The system throws complex scenarios at them, multiple vessels, crossing situations head-on, overtaking often in restricted visibility like fog or heavy rain. The goal is to make the correct responses automatic.
And not just avoiding collisions, but handling extreme conditions.
Right. High-stakes stuff like heavy weather navigation, optimizing the ship's course and speed to minimize stress on the hull, and critically, rehearsing responses to things like parametric rolling.
You mentioned parametric rolling earlier. Can you quickly explain why that's so critical to practice in XR?
Sure. Parametric rolling. It's this really violent, unstable rolling motion that can happen to certain ships, especially container ships, in specific wave conditions. It can build up incredibly quickly and literally capsize the vessel.
Okay. Sounds terrifying.
It is, and you absolutely cannot practice controlling it on a real ship. It would be suicidal. In the digital twin, though, the officers can rehearse the specific maneuvers changing course, adjusting speed needed to break that dangerous resonance cycle, turn a potential catastrophe into a managed event.
Got it. So XR allows safe practice for impossible real-world scenarios. What else falls under Group D?
A big focus is also on bridge resource management, or BRM. That's the human element, ensuring clear roles on the bridge, good communication, using challenge and response, managing fatigue, all the teamwork aspects.
So if you look at priority 2 overall, with Group C on the engineering side and Group D on the navigation and human factor side.
Yeah, you're essentially tackling both the key potential failure points,
Right.
mechanical reliability, and human error. Because often it's the combination of a technical problem and a poor human response that leads to the really big disasters. Now both sides are being trained consistently, objectively.
The potential efficiency gains here seem huge.
Mm-hmm.
So let's pull back a bit. What does this whole XR approach mean for the traditional way of maritime training? Can you give us that sort of before versus after picture?
Yeah, the contrast is pretty stark. Before XR, errors during training or early operational phases were incredibly expensive. Damaged equipment, lost time, potentially injuries, live equipment time was scarce and high risk.
And now?
Now, you have essentially unlimited practice on a digital twin. Make mistakes, learn from them, repeat. No real-world cost. Before, emergency drills were infrequent, risky to run properly, often dependent on weather or schedules, so the actual learning could be minimal. Now, you can run SOLAS-aligned emergency scenarios safely, anytime, anywhere, even mid-voyage. Repeat them until competence is proven by data. And maybe the biggest shift.
Go on.
Before, it took new hires months, sometimes years, to really build confidence and earn the trust of senior officers for complex tasks. Now, with this integrated spatial AI coaching we mentioned, readiness can potentially be accelerated down to weeks.
That acceleration has to be incredibly appealing to the industry, given the talent gap you mentioned earlier.
Absolutely.
Okay, we hear about simulators, in maritime bridge simulators, engine room simulators. They've been around. What makes this approach, as described in the sources, truly different? What's the tech that goes beyond just a big fixed simulator?
Good question. There are really three key differentiators that make this more of a platform than just a simulator. First, and probably most important, is the spatial AI coaching.
Okay, spatial AI coaching. How does that actually work for the training? Let's say they miss a step during that blackout recovery drill you mentioned. What happens?
It's not just a grade at the end. The AI is tracking their movements, their gaze, their actions within the 3D simulation. If they miss closing a critical valve, for instance, the AI doesn't just mark it wrong. It might provide an immediate visual prompt, like a highlight on the valve or a subtle audio cue, guiding them back to the correct procedure in real time.
Ah, so it intervenes during the task.
Exactly. It captures the error, understands the context, and provides personalized help right then and there. It focuses remediation on that specific learner's weak points. So you're actively building competence where they struggle, not just repeatedly testing things they already know.
That sounds much more efficient. If the AI learns where you're weak, the training adapts. Okay, what else? What about keeping the training current? Procedures change all the time on ships and in ports.
That leads straight to the second differentiator, rapid authoring. Traditionally, updating complex simulations was a long, expensive coding process. Months, maybe. This system, according to the sources, allows the client, the shipping line, the port authority to take their own standard operating procedures, their specific safety checklists, and turn them into interactive, measurable XR training scenarios relatively quickly. We're talking potentially hours or days, not months.
So the training stays relevant to their specific operations, their fleet, their equipment.
Precisely. That's crucial for compliance and real-world effectiveness.
Okay, AI coaching, rapid authoring. What's the third piece? You mentioned measurement. How is competence documented?
That brings us to the final elements, digital credentials and deployment anywhere. The system generates verifiable records of skill completion directly aligned to those key industry standards, SOLAS, ISM code, IMO procedures.
So you have data-backed proof of competence, not just a certificate saying someone attended a course.
Exactly. That's critical for regulators, for insurers, for the companies themselves. And importantly, this training isn't tied to one expensive simulation center. It can be deployed on various devices, VR headsets, tablets, even desktops.
Meaning it can be used on board the ship, offline, or out in the yard, not just back at headquarters.
Right. Training becomes accessible wherever the workforce is, whenever they need it, online or offline.
This really does seem to imply a move towards standardization, doesn't it? If everyone's training against the same measurable standard, guided by AI, it potentially removes a lot of the variability you might get from site to site, or ship to ship, or even instructor to instructor.
That's a really important point. It drives a level of consistency in safety and compliance training that was hard to achieve before. It shifts the focus from subjective evaluation to objective, data-driven skill verification.
So wrapping this up, what's the core takeaway here?
I think it's pretty clear. Maritime operations are all about precision, following rules, and teamwork, especially under pressure. XR, particularly with these advancements like spatial AI, makes those really critical, hard-to-train moments safe to practice, repeatable, and, crucially, easy to measure.
Yeah, it seems this technology hits multiple targets at once, improving safety, ensuring compliance, boosting performance, all by using data to pinpoint and fix skill gaps much more effectively.
Couldn't have said it better.
Okay, so here's a final thought for you, our listeners, to consider. If digital twins and spatial AI coaching become widespread, we might see a future where verifiable, objective skill data proof you can perform under pressure in the simulation becomes more important than just years of sea time or seniority in determining crew competence.
Mm-hmm.
What could that mean for how quickly the next generation of seafarers qualify? How promotions work? How the whole industry defines and measures competence? Something to think about.